Okay, since the weather has not been cooperating with us, I'm going to take you through the notes that we would have done today if we had been here, just to keep us caught up and going through the process. So this is the rest of the notes from 8.2. This is finishing off the notes you already have. All right. So here we go. This is just to recap you on the stuff that we did last week of the entire 4-step process of making a confidence interval. So just to remind you, step 1 is to state out the interval that you're making and define the parameter that you're estimating. So this is the part where you say, we need a 95% confidence interval to estimate P. And then you're going to define what P is, whatever that interval is. That's your step 1. Step 2 is that you're going to identify the method, which in this case, right now, we only have one. And then you're going to check your 3 conditions, which is random. Random is that you have a random sample. Normal, so in this case, you're checking n times p and n times 1 minus p, checking that they're both at least 10. And then independent, so population at least 10 times the sample size. Then you're going to do your calculation, show the formula, plug in the numbers, answer. And then you're going to interpret that answer, interpret the interval. So that statement of we are 95% confident that the actual population parameter lies between these 2 values. All right, so we're going to do this with an example. I'm going to take you step by step through this example here. And what I'm going to do is at each point, I'm going to give a couple of seconds of time for you to pause and to try this step on your own using what we've done already. All right, so here's our example. So I'll give you a few seconds to read it. Pause and read it. Okay, and we're going to change this actually. We're going to make it a 99% confidence interval. So this is going to be 99 instead of 95. All right, so step 1, we're going to state the interval that we're going to estimate. So we are using a 99% confidence interval to estimate P, the proportion of pennies that are more than 10 years old in the collection. All right, so that's just defining what P is. And then in our case, for our sample, since 57 were at least 10 years, were at most 57 were more than 10 years old, and 45 were at most 10 years old, then that's 102 in the entire sample, 57 plus 45. And so our P hat is 57 out of the 102 were more than 10 years old. So 0.559. So that's what we're going to use for our P hat from here on out. Okay, so that's step 1. Step 2, you're going to check your conditions. So random, normal, and independent. So I'll give you a few seconds to try that before I show you. Okay, here they are. Here are the conditions. 1 proportion Z interval, which is the only interval that we've been looking at so far. First off, random, we did take a random sample from the collection. Normal, you're going to check n times p and n times 1 minus p. So each of these proportions. We got 57 and 45 as our number of successes and number of failures. Both of those are greater than 10, so that's our normal condition. And then independent. Remember, it's about sampling without replacement, but as long as it's less than 10 times the sample size, then it's not going to really matter. So we're checking 10 times the sample size, 10 times 102, and we need more than that in our population. More than that in our population. So total number of pennies in the collection. All right. That is our step 2. Step 3, we are going to calculate. So I'll give you a few seconds. We need the z-score for a 99% confidence interval. Give you a few seconds to remember how to do that in your calculator. So then in this case, Remember, we want the middle 99%. So if we want the middle 99%, that means 0.5% on each tail. So we want 99 plus the 0.5% that's on the left tail to be 0.995. So you want inverse norm of 0.995, and that should give you about 2.576. So that's what we're going to use. Formula, plug in the numbers, right? There's your p hat, and here's your sample size. This part is your margin of error, so it's 0.559 plus this margin of error, and then here's your interval. There is a way to do this nice and quickly on the calculator, which we'll talk about tomorrow, how to do this on the calculator. If you're wanting to look at it now, it's on page 492 of your book. Page 492 is where you're going to find how to do this on the calculator. It'll take you through it step by step. So if you're looking for that shorter way. But on paper, you need to show this formula, plug in the numbers, answer, regardless of whether you do it on the calculator, so that you're showing the grader that you know how to do these steps, and you know what numbers you're plugging in where and what formula you're using. Okay, so this is our interval. So step 4 is to interpret. Give you a few seconds to write out that interpretation. Let's pause and do that. Okay, so here's how that would look. We are 99% confident that the actual proportion of pennies in Miss Smith's collection that are more than 10 years old, so that's the actual parameter that we're trying to estimate, that the actual parameter of the actual number of pennies that are more than 10 years old is between these two values. Okay, 99% confident that this actual population proportion is between these two values. Okay, so those are our 4 steps. And so if I ask you to construct and interpret, or to calculate and interpret a confidence interval, that's what I'm asking you to do, is to follow those 4 steps. All right, and we've done that with an example before, but that's showing you another example and kind of refreshing your memory on it. All right, this is a good break point to pause and come back if you need to, because we're going to cover another topic here. One more topic. All right, like I said, this is our margin of error. All right, now if we are designing a study that we want to have a particular margin of error, then we can actually control for that based on the sample size we choose. Okay? Another way we can control for that is by making a wider or narrower interval, like a 95% versus a 99%. 99% is going to be a wider interval. All right? But we can also control for it by selecting our sample size. All right, so that's what we're going to look at. Because the margin of error involves the sample proportion, we have to guess the latter value when choosing n. So in other words, what do we make p hat? If we're trying to pick a sample size, we don't have p hat yet because we haven't taken our sample. So how are we going to get p hat? 2 different ways we can do it. Either if we have a previous study that we can work through, then we can look at it that way. Or if we have a guess as to what p hat might be, if we think that it might be 80% based on a poll we took before, or based on, you know, some law of the data, then we can use that for p hat. If we don't, then we're going to use 0.5. And the reason we use that is because p times 1 minus p is going to be at the largest when we're at 0.5. So it guarantees that the margin of error doesn't get larger than that value. Even if p is something different than 0.5, that'll only make the margin of error smaller. So 0.5 is what we're usually going to use for a guess. So these are problems where it says, we want the margin of error to be this. So what should our sample size be? So we know our margin of error and trying to solve for our sample size. So we're going to get the z-score. We're going to usually use 0.5 as our guess, and then solve for n with what we know from our algebra 2. Okay. Example on page 493. So this is about percent of people that are satisfied with customer service, basically. And it says that we want the estimate to be within 3% at a 95% confidence level. All right? So that's what the example is about. So we want our margin of error to be 0.03. Okay? That's what we want to set up. So we're going to set up that equation, and we're going to use 0.5 as our guess. We're going to use 0.5 as our guess. So first off, we need the z-score for 95% confidence interval, which is going to be our 1.96. 0.975 is what you would want to put for inverse norm. We did that earlier in our notes. Then, here's our equation. All right, and we're going to put 0.5. We're going to put 0.5 in for p hat. Putting 0.5 into here, and then we're going to solve for n. Okay? So I'll give you, now more than any other point, I would encourage you to pause and do this. So plug in 0.5 for p hat as our guess, and then solve for n. Because the way we're going to do this, way I would suggest doing it is get the square root out of the bottom, and then it moves the 0.3 over to the other side, and then you should have 0.5 already in for n, and then you should determine what that's going to be and then square both sides. This does it in, these notes do it in a little bit of a different order, but it should get the same thing, which is 1067.111. So remember, we want to round up. The reason we want to round up is because the larger the sample size, the smaller the margin of error. So if we want a smaller, larger margin of error, then we want to round to the higher sample size, since n is on the bottom. So that's how we set up those problems. These are a trickier type of problem, but the basic structure is that you want to plug margin of error is the part of the formula comes after the plus or minus. And so you want to plug all your values in. 0.5 is a guess. If you don't know what the actual proportion is, 0.5 is a guess. And then plug in all your values, solve for n. Kind of like when we were doing z-scores and we're asked where the 70th percentile is in a data set, get the z-score and like solve for the value out of the z-score. This is kind of that same idea, except applied to the margin of error formula. Okay. Tomorrow in class, I'm going to give a quiz, and what the quiz is going to ask you to do is to follow these 4 steps of the confidence interval. Don't panic too much about this quiz. All right. I'm going to let you use your notes. And once the quiz is done, we're going to go over it together. And this is for me to see what things I need to talk about more and emphasize more, how much you're understanding, how much you're not understanding. It's just a thing to help me to see how you're coming along on this. If you want some practice, there's some homework. New homework assignment. Wednesday and Thursday, here's our plan. So tomorrow, I'm going to give you a quiz, and we're going to go through one of these problems. Wednesday and Thursday, we're going to do section 3. If we're not here on Wednesday and Thursday, then I'll do something similar to what I'm doing today. But we're going to go through 8.3 notes. Friday, we're going to look at some free response questions. Monday, we're going to review. Tuesday's going to be your test. Okay? And exactly how we go over things is going to depend on whether we're at school or not. But I will be sending, if we're not at school, I'll be sending you some things and sending you some resources, some files, and some of these presentations so that you have things to look at and have things to work on as we come closer to this test. All right, and hopefully you're staying warm, and hopefully I will see you tomorrow.